Hi guys, today's lesson is lesson 15 on hydrocarbon combustion reactions. So these are basically when you light anything on fire. So what we know about combustion for hydrocarbons is that they're always going to be in this form C and H. So that's a hydrocarbon because you can see a hydrogen and a carbon. These are found on page 5 of your data booklet. So it's a big chart that looks like this, and you can see they're not all hydrocarbons, but a lot of them are there. Like if we look near the bottom, we can see things like octane, pentane, propane. These are all hydrocarbons. Those are going to be essentially what we're lighting on fire. If you think about the gas that comes out of the tables in the science lab, that's methane gas, or CH4. That's what I would have lit on fire when I lit you guys on fire in class. If you really missed that, so did I. Talk to me next year. Maybe I can light you on fire then. So this is a reaction where it's really fast, really exothermic. A lot of heat is given off when something lights on fire. And you need oxygen for this to happen. If you guys have gone camping and you know anything about making fires, you know that sometimes to get the fire started, you'll blow on the fire to introduce more oxygen. If you kind of cover the fire with something like maybe a fire blanket in the chem lab, you're basically eliminating oxygen from the reaction. And without oxygen, this won't happen. Things won't light on fire. The products are always going to be the same. This is actually one of my favorite reactions because 3 parts of it are the same every single time. You always add oxygen and you always get carbon dioxide and water vapor. Okay, let's start with the one that we would have done when I lit you on fire in the chem lab, methane plus oxygen. So go to page 5, look in this chart, find methane, and see that it's CH4 gas. Okay, add oxygen. So most people are really good with the fact that oxygen is a polyatomic element. It's in the small box on your periodic table, and it always comes with a buddy. It's O2, and since the box on the periodic table is gray, it's going to be a gas. Now, these are the reactants. These are the things that I would put together. I'd introduce some kind of spark, and what would be created, or what would be a product, would be carbon dioxide. Now, we skipped over molecular compounds. So as soon as you hear that word carbon dioxide, that's a molecular compound that we didn't study for the sake of time. So you're just going to have to memorize that carbon dioxide is CO2 gas. Some students are using prefixes like mono, di, tri, etc. in ionic compounds. You never write a prefix in ionic compounds. And water vapor. So that's H2O gas. So this whole part from oxygen to water vapor is the same in every single hydrocarbon combustion reaction. So essentially, if you write that down every single time and you put a new hydrocarbon in front, that's what we're doing today. Now we have to think about balancing this. So I'll show you the trick with balancing it. The trick is that on the reactant side, we have 2 oxygens. That's an even number. What's going to throw that off is that we have 2 oxygens on the product side, but we have 1 over here, which makes an odd number. There's 3 oxygens. So a lot of times what happens is we have to put a number in front of the water to make that side even. So we'll put a number like 2, 4, 6, 8, something that would make this oxygen here an even number instead of an odd. So that being said, I like to leave the oxygens till the end because if we're trying to balance the hydrogens and the carbons first, usually that problem will be solved, or we'll just have to double the number that we choose. So I'm going to start with the hydrogens because that's the biggest number I see right there is 4 hydrogens. And I see 2 hydrogens on this side, so I'm going to double it to make 4. I see 1 carbon and 1 carbon, so those are balanced. So now I'm going to do the oxygens, but I'm going to be careful because I have 2 oxygens with the CO2, and now I have 2 oxygens with the H2O. 2 plus 2 is 4 oxygens, so I'm going to put a 2 here to make 4 oxygens. Let's try another one. Hexane. I'm going to go again to my data booklet and I'm going to find hexane, see if I can find it on page 5. All right, I can't see hexane on page 5. So there's a couple different places that we can look. This is the bottom of page 4. There's this tiny little chart that only has a couple hydrocarbons, but it does have a couple that aren't on page 5. So I do see hexane is listed there, C6H14, and that's a liquid. If you can't find it on page 5, it's in your data booklet somewhere. So just search around on different charts and see if you can find hydrocarbons. Now, the part in red from the previous question is exactly the same. I need oxygen gas for a hydrocarbon to burn. It always makes carbon dioxide gas and water vapor, so gaseous water. Now I'm going to start with the biggest numbers that I see. And this one, I suggest you have an eraser with you because we might have to do some fixing. Okay, first thing that I see, biggest number is hydrogens. I see 14 hydrogens. What number can I put in front of H2 to make 14? 2 times 7 would be 14. Now I have 6 carbons. That's the next biggest number I see. I have 1 carbon here, so I'll put a 6 in front to balance. The last thing to balance would be the oxygens. On the product side, I see 12 oxygens and I see 7. That makes a total of 19 oxygens. That's an odd number. There's no way that I can put a number, a whole number that is, out in front of O2 to make 19. I want to steer clear of fractions here and not make this too difficult. So what's the best way that I could make this odd number even? The trick here is to double it. Now, I'm going to erase what I had because I know that I need to double up those numbers. So the 7 and the 6, both of them are going to get doubled right now. 14 and 12. Now you can see that I have even numbers of oxygen, so I shouldn't have a problem from this point forward. But if I doubled the carbons and the hydrogens, I need to double the hexane here. I need to have 12 carbons, and here we have 28 hydrogens, same as this side. Now I can count my oxygens again and do my final coefficient to balance the oxygens. I see 12 times 2 is 24 oxygens. 14 times 1 is 14. Add those together and you get 38 oxygens. So I need to go 38 divided by 2 to get the 19 oxygens that go there. Next example, ethyne and oxygen. This one should be on page 5 of your data booklet if you look it up. And there it is, about the 4th box down at the bottom, C2H2. And if I just double check on my data booklet, I see that it's a gas. And the next part is the same for every combustion question. You need to add oxygen gas, and you will always get carbon dioxide gas and water vapor. All right. First thing that we've been starting with on most of these questions has been the hydrogen. There's 2 hydrogen here and 2, so they actually already balance. But see if you can figure out why I'm going to double the hydrogen in this question. The reason why I need to double it is because I need to make the oxygen an even number. It's never going to balance with this even oxygen if I've got one single oxygen over here or an odd number on the product side. So if I double the hydrogens, I need to do the same here so that I have 4 hydrogens on each side. By doing that, I've also doubled these 2 carbons. So I've got 2 times 2, which is 4. And now I can do the oxygens at the very last step. I see 4 times 2 and 2 times 1, 10 oxygens on the product side. So I need 10 oxygens on the reactant side. 5 times 2 is 10. This is now fully balanced. Combustion of sucrose is next. If you pause the video and look on page 5, you should be able to find sucrose and write it down. Sucrose is C12H22O11 solid. And the word combustion is all we have to say in this section for you to automatically know that it's adding oxygen and creating carbon dioxide and water vapor. You always know that when it's combustion. You should get really good at writing those last 3 parts because you do it for every question. Now, this one probably looks a little bit different to you because the first thing has an oxygen in it. We've never seen that before in this set of notes, but you can still do this. We can still balance the carbons, hydrogens, and oxygens on either side, but this one probably won't have that odd even problem because there's 11 oxygens on the left-hand side. That's an odd number. So we might be able to get away with the odd numbers matching up. Let's start by just going to the biggest number, working there, and then seeing if we need to erase and try again. 22 hydrogens. I'm going to put 11 in front because 11 times 2 is 22 hydrogens. I'm then going to make 12 carbons on the product side. And lastly, I'm going to count how many oxygens I have and force my number of oxygens on the reactant side to be the same if I can. 12 times 2 is 24 oxygens. 11 times 1 is 11 for 35 oxygens total. Now, the reactant side needs to have 35 oxygens. I don't want to put a number, other than a 1, of course, in front of sucrose because my carbons and hydrogens are already balanced. So if I can leave it as a 1, I don't disrupt all the work that I've done on the product side already. So what I have already counted is 11 oxygens. So I don't need 35 on this side. I'm going to subtract 11. I need 24 oxygens right here to add to the 11 that I already have and balance the equation. 24 divided by 2 is 12. Sometimes there's a little bit of back and forth with balancing, and you just kind of start somewhere and see what happens. But if you're starting with the biggest number and remembering that the oxygens can sometimes be that odd even issue with combustion, you should be okay. One other thing that I want to mention, not a lot of students are doing this, but I did see it, is your numbers in front. You want them to be as simple as they can be. So this question is perfectly fine. 1, 12, 12, and 11, they don't all divide by something. But sometimes we see people who maybe put a 2, a 24, a 24, and a 22. Do you see how every single one of the red numbers can divide by 2? That means it's not fully simplified. That's what we're looking for when we balance equations. So if you notice that you've done that, you just need to divide them all by 2 and you'll get the correct answer. We always put our coefficients in simplest form. Now, I don't want you to see something like these 12s and start dividing them by 2 or by 6 or something. You only need to divide if every single number divides by the same thing, which usually doesn't happen. Not a lot of students are making this mistake, but it's worth reminding you about. Now there's a worksheet on combustion that you need to complete. And now that we've done all 5 types of reactions, I want to do a quick review on all the different types so that you can go back in your notes and you can try and recognize the type of reaction that we're showing. Okay, so there were 5 types that we did. And we'll talk about what you're looking to determine if it's that type of reaction. The first 2 that we did, and I did 2 together on purpose, is we did formation and decomposition. We did these together on purpose because they're complete opposites of each other. Formation was when you took an element, you added another element and maybe even more elements, and you got a compound. Like taking some sodium, adding some chlorine, and getting sodium chloride. Decomposition was the same thing in the reverse order, taking a compound and breaking it up to be all of the elements added together. The next 2 reactions that we did last week were single replacement and double. Single replacement was when you had an element plus a compound creating an element plus a compound. Now, what you would have noticed is that whatever this element was, whether it was a metal or a nonmetal, it switched places with its counterpart in the compound. So let's say this element was a metal. It would have switched places with the first element in the compound because it was also a metal. Same thing if it's a nonmetal, it would then just have switched with the second element, a nonmetal. Double replacement is when you have compound, compound, making compound, compound. And the way that I taught you this is just find the metals in the compounds. So let's pretend the first things here, it's not an ionic compound that I've just written a word, but let's pretend it's an ionic compound. The first 2 would be metals. They switch places, and that's a double replacement reaction because you've got compound plus compound, not element plus compound like the last one. The last type of reaction is what we did today, called hydrocarbon combustion. Think fire. And this is where you have some kind of carbon and hydrogen mix, like C2H2, CH4. These X and Y's can be any number combination. You add oxygen gas to start a fire, and you get carbon dioxide gas and water vapor. So if I gave you a quiz that just had a bunch of chemical reactions written on it, I could ask you, okay, look at what you have there. What type of reaction is it? Is it formation, decomposition, single replacement, double replacement, or hydrocarbon combustion? So take a look back in your notes and see if you can spot all of the different types, and see if just by looking at the chemical equation, if you can tell what it is. Your practice booklet has lots of questions for this, and even some questions on telling different types. So practice those and let me know if you need any help. I would love to help.